Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard to 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous videos, I was actually discussing the 9th chapter of 9th standard science subject. So in those videos, I have explained about the gravitational force, and I have also explained about the universal law of gravitation, and I have also explained acceleration due to gravity. From universal law of gravitation, we came across that force, gravitational force F is equal to G, that is gravitational proportional constant, capital G, into M1, M2. So this is the gravitational force between two objects, that is one object which has mass m1 and the other object which has mass m2. So in that case, gravitational force between these two objects will be G into m1 m2 divided by distance, whatever the distance it is there between those two objects, the square of that distance is there in the denominator. So this is one equation which we have saw, and also we know that force, gravitational force is basically a force. Because it is a force, then acceleration comes into picture. So whatever acceleration is caused due to the gravitational force is known as acceleration due to gravity. So F is also equal to mg. So m is the mass of the object which is under the gravitational force influence. So now we got this particular equation as well, and we calculated the acceleration due to gravity of Earth by substituting mg in the place of force. So there we got g m1 in m2 divided by d square, that is equal to mg, where m1 can be written as capital M because capital M was the mass of Earth which we have taken, and m2 can be written as just m. So this m is the mass of object which is under the influence of gravitational force of Earth. By considering this, we cancelled the mass of the object which was there on the either side of the equality symbol, and we got this particular equation. So we substituted in the place of distance the radius of Earth, where radius of Earth was from the center of Earth to the surface of the Earth, assuming that Earth is almost in the spherical shape. So now, after substituting mass of the Earth and radius of the Earth and substituting this particular proportionality constant, we got acceleration due to gravity for Earth as 9.8 meter per second square. So this also we had discussed in our previous video. And also we discussed equations of motion for an object which is under free fall. So here acceleration due to gravity will be coming into the picture for objects which are under free fall, and equations of motion for such kind of examples can be taken as v is equal to u plus gt, s is equal to, s is the distance, so s is equal to ut plus half gt square, and we also saw the third equation of motion, that is v square is equal to u square plus 2g into s. S is the distance. So these are the equations of motion which you can apply for an object which is under free fall. So in that case, in the place of acceleration, you can substitute acceleration due to gravity of Earth. So based on these equations, whatever we have discussed in our previous videos, based on that, we have three examples in this particular chapter. So we will look at those examples one by one. So coming to the first example, that is example 9.1, they have given mass of Earth. So mass of Earth, I'll take that as ME, that is equal to 6 into 10 power 24 kg. And they have given mass of Moon. So mass of Moon, I will call that as MM. So this is subscript where this indicates Earth and this indicates Moon. So mass of Earth and mass of Moon. So mass of Moon is given as 7.4 into 10 power 22 kg. And they have also given the distance between Earth and the Moon. So here distance d from Earth to Moon is equal to 3.84 into 10 power. So 3.84 into 10 power 5 kilometer. So this is the distance between Earth and the moon. And we also know the proportionality constant. So that is equal to 6.673 into 10 power minus 11 Newton meter square per kg square. So this is the value for proportionality constant G. So based on these values which you have in this particular question, you have to calculate the gravitational force exerted by Earth on moon. So gravitational force exerted by Earth on moon can be denoted as Fe, that is equal to G into MM divided by D square. So here you can just substitute the values. So 6.673 into 10 power minus 11 in the place of G. So everything is in SI unit. So directly you can go on substituting. So mass of Earth is given as 6 into 10 power 24. And mass of moon is given as 7.4 into 10 power 22. So now in the denominator you have D square. So D square is the distance. Here distance between Earth and moon is given in kilometer. This you should convert into SI unit. So kilo means it is 10 power 3. So in the place of kilo I can write 10 power 3. So 3.84 into 10 power 5 into 10 power 3 meter whole square. So after solving this, you will get the answer for this force, gravitational force exerted by Earth onto the moon. So that is equal to, let us separate all these 10 powers one side. So 6.673 into 6 into 7.4, we'll group them together, and this 10 powers we can group together. So 10 power minus 11 is there, 10 power 24 is there, 10 power 22 is there. So into 10 power minus 11 into 10 power 24 into 10 power 22. So divided by distance, you can clearly see 3.84 whole square is there. 10 power 5, 10 power 3 is also there inside the bracket only. So 3.84 whole square will be there. So for 10 power 5, if you take whole square, so according to the exponents rule, which I have actually discussed in 8th standard mathematics, if you want, you can go to the 8th standard mathematics, where in that one particular chapter was on exponents and powers. So you can refer that. So if a power m whole power n is there, then that is equal to a power mn. So now 10 power 5 whole power 2 is there, that is square. 10 power 5 square is there. So 5 into 2 you can do. So 5 into 2 will be 10. So that means 10 power 10 will be there, into 10 power 3 whole square is there. So 10 power 3 whole square means 3 into 2. So that is 6. So 10 power 6. So I have separated all these 10 powers one side. So now let this be in one particular position. So now gravitational force exerted by Earth on moon is equal to 6.673 into 6 into 7.4 into, we can solve this 10 power. So here 10 power minus 11 is there, 10 power 24 is there, 10 power 22 is there. So you can just apply the exponents rule. So 10 power minus 11 plus 24, because base is same. Here you can see for all these three, base is same. That is 10, 10, 10. So directly you can add these powers. So minus 11 plus 24 plus 22 will be there. So minus 11 plus 24 plus 22 will be there. Divided by 3.84 whole square into 10 power. Here you can see 10 power 10 is there and 10 power 6 is there. So base is same. So 10 plus 6. So that is 16. So 10 power 16 will be there. If you take this 10 power 16 to numerator, it will become 10 power minus 16. So 6.673 into 6 into 7.4 divided by 3.84 whole square into 10 power minus 11 plus 24 plus 22 will be 22 minus 11 is 11, 11 plus 24 will be 35. So 10 power 35, and if you take this 10 power 16 to numerator, it will become 10 power minus 16. So into 10 power minus 16. Again here base is same, you can just add 35 and 16. So force exerted by Earth on moon will be equal to 6.673 into 6 into 7.4 divided by 3.84 whole square into 10 power 35 into 10 power minus 16 is there. So base is common. So 10 power 35 minus 16. So 35 minus 16 will give you 19. So 10 power 19 will be there. So when you do this particular calculation, you will get 20.09 into 10 power 19 is there. So 19 Newton, because always force have SI unit equal to Newton. So force exerted by earth onto the moon is equal to 20.09 into 10 power 19 Newton. Or you can just write this as 2.0. So this 09 can be round off to 20.1. So if you bring this decimal point this side, then it will become 2.01 into, here you have to increase the power. So 10 power 20 Newton. So 2.01 into 10 power 20 Newton, or 20 into 20.09 into 10 power 19 Newton. So this is the force exerted by earth on the moon. So coming to example 9.2, here there is a car which is there at a certain height, and this particular car falls off from this particular height, and this particular car falls to the ground. So now you have to calculate what will be the velocity of car when it is just striking onto the ground. So that means when this car is falling, it is coming into the influence of gravitational force. That means this car is under free fall. Initially this car was at rest, and from there this car has fall down. So when it was falling down, you have to calculate the speed of this particular car just before it was hitting that particular ground. So you have to calculate that final velocity, and here they have given car was initially at rest. So u will be 0. So initial velocity will be 0. And here they have given acceleration due to gravity as 10 meter per second square. So we have learnt that acceleration due to gravity is 9.8 meter per second square. For calculation purpose, we are just taking approximate value of gravitation, which will be nearly equal to 10 meter per second square. So this is what they have given in the question. So that means they are giving acceleration due to gravity, so 10 meter per second square, because when car is falling to the ground, it is coming into the influence of gravitational force, and acceleration which it is gaining because of that gravitational force is acceleration due to gravity. So that is 10 meter per second square. Now based on this particular data, you have to calculate 3 sub questions in this particular example 9.2. So in that first question, they are asking you to calculate the final velocity. So this particular value. So what is the final velocity? In order to find out final velocity, you can use the first equation of motion. So that is v is equal to u plus at. In the place of a, you can substitute g, because here acceleration is acceleration due to gravity. So v is equal to u plus gt. So what is initial velocity? Initial velocity was 0, plus what is acceleration due to gravity? That is 10. And one more important thing which they have given in this question is it takes 0.5 seconds to fall to this particular ground. So here you can substitute 0.5 second in the place of time. So 0.5. Everything is given in SI unit, so directly you can substitute these things. So 10 into 0.5 will be remaining. So 10 into 0.5 is nothing but 5 into 10 is 50. So 1 point is there, 1 decimal is there. So you can just keep 5.0 meter per second. So 5.0 meter per second or 5 meter per second will be the final velocity of this car. That is, this is the velocity at which this car was falling onto the ground just before it was striking to the ground. So now coming to the second question in the same example, here they have asked you to calculate what is the average speed. So always remember, average speed is always equal to the initial speed and the final speed divided by 2. So what is the initial speed? Initial speed was 0. Final velocity which we have calculated here was equal to 5 meter per second. So divided by 2. 0 plus 5 is 5 divided by 2. That is equal to 2.5 meter per second. So this is the average speed of this particular car when it was falling towards the ground. So now coming to the third question in the same example. So in third question, they are asking you to calculate the height from which the car has fallen down. So height means basically it is the distance covered by the car from its initial position to final position. So that distance S is equal to ut plus half. In the place of A you can write g t square. So here initial velocity is 0. So that's why this entire term becomes 0. So S is equal to half gt square. So S will be equal to half into acceleration due to gravity is 10 into 0.5 whole square. So now 2 ones are 2, 2 5s are 10. So S is equal to 5 into 0.5 square means it is 0.5 into 0.5. So 0.5 into 0.5 will be 5 5s are 25. So 5 into 0.25 will be there. So 5 5s are 25. So 5 will be there. 2 carry. 5 2s are 10. 10 plus 2 is 12. So 125. So after 2 decimals you have to put this particular decimal point. So 1.25 meter. So this is the height from which the car has fallen down to the ground. Coming to example 9.3, here a particular stone was thrown upwards. So let's say a person is there and he has thrown a particular stone upwards. So now you have to calculate the height, the maximum height to which this particular stone reaches. So maximum height you have to find out, and you should find out at what velocity this particular person has thrown this stone. So whenever a particular object or a stone is thrown vertically upwards, gravitational force will be applied on this particular object oppositely. That is, this particular gravitational force is in the opposite direction to the direction of motion of that particular object which is traveling against the gravitational force. So because of this gravitational force, the velocity of stone goes on decreasing, and at one particular highest position, this stone or this object comes to rest for few milliseconds or microseconds, and then it starts falling down towards earth. So you have to calculate what was that initial speed, and final speed is equal to 0. So here they have given this particular stone which was thrown upwards by this person. It has reached maximum height which is equal to 10 meter. So that means basically they have given distance as 10 meter. They have given initial velocity, they have given final velocity that is equal to 0. Now you have to find out what is the initial velocity. If we use the first equation, that is v is equal to u plus gt, here we don't know what is time. So that's why we cannot use this equation. So if we use the third equation, that is v square is equal to u square plus 2gs, here we know what is v square, and we also know what is acceleration due to gravity, and also we know what is the height. Here time is not there at all. So this particular equation we can use to calculate the initial speed. So now when this particular stone is thrown upwards, here the direction of motion is opposite to the gravitational force. So gravitational force is acting in this direction, and the direction of motion is opposite to the direction of gravitational force. So that's why here acceleration is equal to minus g. So this g is acceleration due to gravity, and here gravitational force is opposite to the direction of motion. So you have to consider minus g as your acceleration. So if you use the third equation of motion, that is v square is equal to u square plus 2as is there. So in the place of acceleration, I should take acceleration due to gravity, and that is in the opposite direction. So gravitational force is acting opposite to the direction of motion. So I have to take minus g. So 2 into minus g into s will be there. So v square, directly you can substitute v square as 0 because final velocity is 0, is equal to u square plus 2 into g is, the value of g is 9.8 meter per second square. So you can take minus 9.8 meter per second square into the height. So here distance is the height. So the maximum height here it is equal to 10 meters. So 10. So 2 into minus 9.8 into 10 is there. So 0 is equal to u square plus 2 into minus 9.8 into 10 is there. So when you solve this, this will be equal to 0 is equal to u square plus 2 into minus 9.8 into 10 will be minus 196. And if you bring this minus 196 to LHS, it will become plus 196 is equal to u square. So now u square is equal to 196. So now you can take square root on both sides. So now you can take square root on both sides. So when you take square root on both sides, so u square will be having square root and this 196 will also have square root. So when you take square root of u square, it will be equal to u. So now when you take square root of 196, that is equal to 14, and when you take square root of u square, that will be u. So u is equal to 14. So SI unit is meter per second. So now you have got the initial speed, that is 14 meter per second. Now in the same question, in the same example, they have asked the second question where you have to calculate the time taken by that object to reach that maximum height. So directly you can use the first equation, that is v is equal to u plus gt. So in the place of g, I'll take minus g into t. So now 0 is there. So 0 is equal to u is there. So u is 14 meter per second plus minus g is minus 9.8 into t is there. So now if you take this 14 to LHS, it will become minus 14. So minus 14 will be equal to minus 9.8 into t. So now if you bring minus 9.8 to LHS, so minus 14 divided by minus 9.8 will be there in the denominator, which is equal to t. So here t is equal to minus 14 divided by minus 9.8. So this time we are getting as minus 14 divided by minus 9.8. Here to remove this minus, we can multiply this with minus 1 into 14. So this minus 14 can be written as minus 1 into 14, because minus 1 into 14 will be minus 14. And in denominator also minus 1 into 9.8 can be written. So here minus 1 divided by minus 1 will give you 1. So here minus 1 and minus 1 gets cancelled with each other. So finally you will be having 14 divided by 9.8. So when you do 14 divided by 9.8, so you will get 1.429 seconds. So here time for this particular object to reach the maximum height of 10 meter, it has taken 1.429 seconds. So this 1.429 can be round off to 1.43. So this 29 you can just round off to 3. So 1.43 seconds is the time taken for this particular object to reach that maximum height. So this is all there in this particular video. The further concepts which are there in this chapter, I will be teaching in my subsequent videos. Like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.